Okay, this is data channel example number 2. This time we're going to take a look at storing position and alignment information. We're going to birth a bunch of particles all over the surface, have them look at this other object, pick a position and alignment, store that, and then we've got this animated kind of this brown box here, which is going to be kind of our activator. And as it moves across and encompasses all those particles, they're going to fly off and fly onto their position on the teapot. So pretty simple example. So let's go ahead and set this up. We'll call this DC example 2. And the first thing we need to do is create some particles on that surface. And we're going to try to keep all of our particles just in one group. So we're just going to work with the all group right now. And remember, it's a good idea to only use one particle group in case you ever have to export in a production. If you switch particle groups and you try to export, it will break the keyframes. So something to watch out for. Okay, so we're just going to go ahead and use a birth node surface black box, which allows us to pick a node that we want to create particles on. We're going to go ahead and turn on show mesh, and we'll turn off the dots. We actually need to expose the particle input for that surface position so that each particle who's being created picks his own unique position and sets it. We're going to go ahead and disable that standard shape, and instead we're going to use this kind of axis helper object that we have down here. It's oriented and has X, Y, and Z on it so that we can see exactly how the particles are oriented. So we'll go ahead and pick that object. And one of the things that we want to remember to do with geom instance is always use the normalize option. It tends to be much faster with viewport updates. Okay, and we're going to change that size a little bit, remove that variation, and we'll go ahead and kind of scale them as needed. Okay, so here we've got our particles created. Let's actually go ahead and create a few more. Let's make 500 of them, or even say 5,000. Although that might slow our viewport down a little much, especially with the recording software. So we'll go ahead and throttle that back. Let's go 1,000. Okay, so next rule we need is we need a rule that is going to pick a point. We'll call this store surface info. And what we're going to have happen here is the all particles are going to, at birth, so that it's only at one time in their life, at one time in their life they're going to look and they're going to pick a point and alignment on that teapot node. So let's go ahead and get a node helper out here, pick our teapot, and we're going to need some information about that object's geometry. So let's connect that node to the surface position. We want face information. Let's randomize it. And this is going to be per particle, so we're going to connect that particle connection. And then what we want to do is we want to go ahead and store 2 data channels. And let's go ahead and make those data channels. We'll select our all operator. And the first data channel that we're going to want is going to be our position. We'll call it new position, or new posts. And then we're also going to want an alignment, so we'll call that new align. So we've got 2 data channels. Number 0 is the position and 1 is the alignment. So this is going to be our this will be our position one, this one right here. And we're going to rename this operator. We'll call this DC0, and the reason that we actually rename the operator, it doesn't really matter in a small example like this, but on a big production scene, anytime you're using these data channel operators, if things change, if your groups end up changing their channels, you may lose track of what's supposed to be assigned to what. So, and especially if you ever have to come back into the dynamic tree and figure out, what is supposed to be assigned here and what's it supposed to be. It's a good idea to go ahead and name these operators something short and logical so that you can easily know how it was supposed to be configured. So we're going to control when these data channels get assigned, so we're going to expose their on inputs and connect it to the particle age at birth. And of course these data channels are being assigned to this particle group here, so we'll make that connection. And this data channel is number 1, so we're going to increase this. And this one's 0, that's okay. So 0 is going to be our position, so we're going to expose the 0.3, and 1 is going to be the alignment, expose that. So we'll just connect the alignment here and the 0.3 to the position. And of course notice that we could connect that 0.3 to any of these values. but we definitely want the position. Okay, so that's all fine and dandy. Let's go ahead then and let's make an activate rule that's going to tell these particles, you know, once this box, once they're inside this box, we want to go ahead and put them into a mode or a mindset where they can go ahead and fly over and attach themselves to that other object. Now, one of the real common ways to do it, like I said before, is to create a separate group and just have them switch groups and then create your next rule that applies only to that group after it's been changed. But again, that's a bad idea. You don't want to switch groups all the time. It gets to be a little chaotic. So what we're going to do instead is we're going to use a memory operator to store a Boolean that's going to tell these guys whether or not they should be moving. So, but first we need to do an in-mesh test. Let's get another node helper out here. We need to detect, let's get that TP out of the way. We need to know, let's actually rename, oops, we don't want to move that quite like that. Let's call this activate, or activator. Okay, so activator, this box, is going to be our node that we're going to detect. And we want to detect the position of each of these all particles. So if the all particles position is in this node, then we want to go ahead and set a memory value. Well, you know, we could even just make another data channel, since we're in data channels. Remember, the nice thing about data channels is they actually get cached if you cache the dynamic sets. Memory values do not at all, so something to remember. If you ever need to, if you're going to layer your caches and, you know, cache something and then create another set of rules that operate on that cache, and you want to be able to access stored values, you're definitely going to need to use data channels. Okay, so in this case we're going to go ahead and we've got a data channel 2 for activate. Let's rename our data channel thing. This is our activate. Set it to 2. Okay, this is the particle who's going to be getting this data channel. This is when this data channel is going to turn on, and the value that we're going to store in that integer, remember this is an integer that we're going to use, it's just going to be true or false. And so we can actually just create a Boolean with the checkbox there. So it is true, so it's in integer form, its value is going to be 1, of course, and if it's not in that box, then it'll be 0. Okay, and then so the last rule that we need is just something that tells them to move. And so pretty simply, we're just going to say all particles, and we're going to use their outputs here. We're actually going to need all 3 of these. What we want to do is we want to use a operator called bring to, which is going to take a particle from one position and orientation and bring it to another position orientation. We're going to affect the all particle group with that. For now, we'll just use the old, what's called the old style. And we're going to go ahead and expose the on input of the bring to so that we can control when this operator affects these particles. And remember, it's on a per particle basis. Each one of these particles stores its own data channel values. So we can go ahead and use the activate to control that. And then we're going to have the new position be there and the new alignment fed into there. Okay, well, we're getting a little redraw pain with all these particles. We're going to go ahead and tone this down just for this example. Unfortunately, I don't have the world's strongest video card, but it's not so bad. Okay, and so we can see all these particles now flying across and flying onto the teapot. And of course, as this activator box moves across there, that is what tells them, hey, you are able to go ahead and move now. Okay, so it flies over as such. That all looks good. Then let's come in here and we'll take a look. And we can see that just like when they were born, these particles, their z-axis is pointing off of the surface geometry normal. So So this, again, just another pretty simple way to go ahead and use data channels with particles in order to store variables for each and every one of those particles. So they each have their own unique value that's being stored in this data channel. And of course, the bonus with data channels, again, is that they do get cached if you cache your dynamic sets. If you use memory operator, those are not cached. Okay, so that's pretty simple. Let's go ahead and we'll just save this and then we'll go move on.